Morning. So SwiftUI is huge, but I want you to know the things that I show you will be not true anymore in a couple months. The syntax is going to change, but SwiftUI is how we're going to code for Apple platforms, so it's hugely important. So this is just a little bit about SwiftUI. In the old days, maybe the very old days, I don't know how many of you have been around since the first iPhone, when we programmed it, we were very specific. We said the label goes exactly here, and then our designer said, no, it doesn't. And so we'd move it down a pixel, because that looks much better, doesn't it? And that 101 was measured from the top of the screen down to the top of the label, and the problem was then when we rotated the screen, it looked like this, and our designer said, no. So we wrote conditional code. And then we had this label, and Apple introduced a Retina screen, and our label looked like this now. And so Apple had taught us, don't think in pixels anymore, think in points. And so we said, okay, I can do that. And then, of course, they gave us a bigger phone. We got this together, and then, so they said, well, we've got auto layout for you. And auto layout was how we gained flexibility, but it was a real challenge to us and also to our designers, because the reason our designers loved this native platform is they said it could look exactly like this. In a browser, we got many looks, but on the phone, it looked exactly like this. And so what we lost is this pixel-perfect design. And there were things that we lost in code along the way. When we started coding table views, we wrote them like this. We said, the text in a cell should be this. And Apple said, yeah, we're going to break all your code. You actually have to say the cell has a text label, and its text looks like this. And so all these things they've learned have come back in SwiftUI. So in the old days, here's how we would set up a label. We'd set the text color to white. And those of you that, how many of you code in Swift? Aren't enumerations wonderful? You can't type in things that are wrong. We could say the text alignment is to be centered. We might put something in the text field, and then we put it on the screen. A button is a little harder. Oh my God, there's so much code. I know, but. So here's how we set up our button. Here's what it displays, and we have to say when it displays it, because if we press the button, it might say something else, and if it's highlighted. So in normal state, it says increase. We put it here on the screen. We put it precisely there on the screen. We add it to the view. But what a button really does is it's got to do something. And one of the things that Apple did early on was they said, you know, we notice when someone presses a button and they realize, oops, I didn't mean to do that, they slide their finger off. So if they touch up inside, they probably meant to do it. So that will be the action that we care about. And what they actually do, we'll do with this selector. And so that we can put this action somewhere else so that you can do it in a GUI or you can do it in code. And so our action looked something like this, like increase the value. And increase the value, we talk to the model, and we tell the value increase by 1, and then we turn around and tell the label, hey, the value has updated, show the new value on the screen. And this is what we thought of as classic controller code. You talk to the model, you talk to the view, that's what a controller does. Yeah, we don't have those in SwiftUI. So SwiftUI, let me say it again. It's kind of a big deal. So in SwiftUI, here's how we write code like that. In SwiftUI, we have these things that conform to view. And the content view is a struct, which is a detail that's important to some of us, but every view will have a body somewhere that says, here's what you display. And what we're going to display is some text on the screen, and maybe a button, and maybe a tab, and maybe, so we return not what you might expect, but this is something new in Swift 5.1, we return some view. It says, I don't know what kind of view you are, I don't really care, you know what kind of view you are. In this case, it's text, and in the old days, meaning last week, we would write it like this. But as of Swift 5.1, if you have a one-line method, you can get rid of the return. And this is good because it keeps other people from understanding our code. And so if I have this code, this is what it looks like on the screen. Thank you, I did that myself. That's all. So let's add a button. You'll see spaces here where other code will go in a minute, but a button does two things. It displays something, but just like we did in the days of that text on the table view cell, we put the increase inside of a text. So that's the label inside of the button that is displaying everything for us. And the button has to do something, so we put that in as an action, and an action is a closure because, again, otherwise anybody could read our code. So I have text and I have a button, but I said a minute ago, this thing, if you have only one thing being returned, you don't need the return, but I'm giving you back a text and a button. That's more than one thing. So we organize it on the screen in some sort of a container, and in our case, we're going to use a vertical stack. So we're going to have a vertical stack and say, put the text here, put the button here, and it looks like this. I don't expect applause every time. You might have noticed that they're kind of close together, and so SwiftUI says, well, we can specify padding in there, and padding, you can tell me how much padding, or you can just say use the default padding. You can tell me to pad it on the top and the bottom. You can't pad it on the left and the right because we're built to be read in each direction, so you pad it leading and trailing. And so when you do that, we get just a little bit of breathing room between the button and the text. And we feel great. We have this little thing that has communicated everything we need, and we have our text, and we have our button. But remember, when we used to have our button press do something, it had to communicate back to the label somehow and say, hey, label, I need you to update the text. If you look at our SwiftUI code, the label doesn't have a name. How do we talk to it? And the answer is we don't. It's just a horrible app. It doesn't do anything. So in order to get it to do something, we provide state. We provide this value. And when we provide this value, we say, look, here's how we're going to change the value. We're going to increase it in our action somehow, and somehow that's going to be displayed in the view. Now, it is a var, which in Swift means it can change, but we're a var inside of a struct. Vars inside of a struct is a problem because if the var inside of a struct changes, then the whole struct has changed. It's changed who this thing was. So Apple made up yet another new thing in Swift 5.1, and this is these property wrappers that are now being discussed on Swift Evolution, and it allows us to say, yeah, the var is part of the struct, but it's really kept outside of it, so we can change it. It's a cheat. But it's a wonderful cheat, because it says, okay, button, you can change this value that's inside of you without worrying about what you're doing to me. And so you change the value updates, and the view says any part of my view that depends on that value has to be redrawn. And so automatically the text will redraw itself with the new value. So we don't have to have the button communicate with the label. The button just changes the state, and the text field's sitting here saying, just call me back when you change, and it gets called back. So, we communicate through this value. Because arrows will communicate this better, let's replay this with arrows. You press the button, that updates the value. The value gets updated, high-priced animation there. When it gets updated, everything that depends on that value gets updated. And so that's how things work in SwiftUI. And so now I get a live shot of this actually increasing. Ooh. Oh, there's more. The problem is, with most of the demos that you see with SwiftUI, they look like this, and everything is together. The layout, the content, the behavior. We want to separate some of these things. So let's separate these things one at a time. Let's pull out the text. So let's define this new thing that will display the text, and I'm going to call it the value display. And the value display is a view, and any view must have this body computed property. And it has this text thing displaying the value. And you say, well, that's great, but what's the value? The value is sitting here in that other thing that we had. So we want the value to be here as well. We can't call it state because state says I'm keeping track of it. And so we want the value, and the way we say, not my value, but I want to be in sync with the other guy's value, we use the keyword binding. And so now we're binding to the other guy's value. So in my content view, the state is holding on to the real value. When the button presses, that will update the state. And instead of the text showing the value, I'm going to link to my new thing, my value display, and I pass it a link to myself. I say, look, you're connected to this value. That's the $ in front of the value. It says, I'm not giving you the actual number, I'm just giving you a link to my value. So when this updates, all my pieces can be connected this way. Let's pull out the button as well. If I pull out the button, I have that same action. I'm going to put it inside something called increase button. It's a view. Every view has a body, but it also has a binding to that same value. So the button is connected to the value, the text field is connected to the value. They're just using someone else's value. So here's where we define what things look like. Inside of it is my button. My button has this text that says increase and has some action. And just for kicks, let's move the action somewhere else so that all my code is separated so that when my designer says, I want to change something, I know where the code is that changes the look. And when my architect says, I want to change something, I know where the code is that changes how the thing behaves. And so I'm going to move my behavior down here to this thing called increase value. And because we're using closures, I can just use the name of the function, increase value, like that, and it's very fluent. When I press my button, I increase the value, and we all have sort of an idea. And so now if we go back to our overview, I've got my value, I've got my button, and so when you can look at this as a whole, you say, what does my app look like? It's a vertical stack with my value display with some padding around it and a button. What do? Well, I look inside at what the button does, and I say, well, when you press it, it does this. What do they look like? I look at the two pieces that describe where it looks like, and now we've separated our layout from our content from our display. And so SwiftUI doesn't have to look like the demos look. But Daniel, show us a more interesting application. Oh my gosh, I thought you'd never ask. So here's an application to record your mood. I'm very happy. I'm happy because I'm in Barcelona for ADDC. I record my mood. I check my history of all my moods so far, and I look at the specifics. So, takeaway 1. So, the point of this example is it has all the pieces, but it does look ugly as sin. So it has components like it had a text and a text field and a slider and a button, and I had some drawing in it. I had containers like not only the vertical stack, but there's horizontal stacks, and there's Z stacks so that we can stack the face coming out to you. So it's the circle, and then the eyes, and then that mouth. I have navigation. There were tabs in it, there were navs, there were detailed views, and finally, I had 3 different versions of state. I had the state you saw before, the binding you saw before, and the last thing we'll do this morning, which is object binding. So at the top level, I see a tabbed view. If you think of it, it was 2 tabs. It was the face view and it was the history view, and this captures that. And now I can break each one out into their own file, and so I have the mood entry view. Remember my design? I'm just admiring it for a moment. So I have the face view, I have a slider, I have a text field where I can enter text, and I have a button. And so that's how this looks in code. I have a face view, I have a face slider, I have a text field, and I have a button. You'll notice the face view and the slider are linked to the mood. As I moved the slider, I was changing the mood being displayed. The text field was the message that I'm storing away, and the button takes that message and that mood and somehow creates a new item in my history. So let's look at the face view. The face view looks like this. It's a Z stack, so it's in Z order. Z stack means painter order, so whatever is first is what you painted first, and the next thing appears on top of it, and the next thing appears on top of that. And so I began with circles, eyes, and a mouth. It's awesome. I fill the circle with a color that I determined from the mood, and so I look at the mood, and I'm going from red to green, and I'm just finding values in between red and green based on your mood. So this is what I want, and so I go to draw the mouth, and when I'm experimenting, the mouth is about 15 points wide. So I'm going to stroke it with a line that's 15 points wide. And I'm so proud of myself, it looks great, and then I rotate it, and it looks like this. And so I do what any developer does. I look online, but it's a 2-week-old technology, and so no one knows. So I tweet it, and someone says, yeah, I ran into that. Use the geometry. Using the geometry lets us listen to our designers. And so if I use the geometry and I want to set the size of the eyes and the size of the mouth and the line width for stroking the mouth, I'm going to put my Z stack inside of a geometry reader that says, well, how big are you? And the geometry reader says, well, I'm this big. And so I say, well, okay, then I'll use the this bigs to draw it, and now no matter what size my face is, everything is relative to those sizes. I take the whole size of the face, and everything is in percentages of that. And so now it looks good on my iPad. It probably looks good on my watch. It looked great on my Mac. The same face, well, looks good. If you think it looks good here, it looks good everywhere. It's a judgment thing. So I've got my eyes, my mouth, everything dependent on the size, and now it's time for me to look at my table view. And so I look at one of these table view cells, and I want it to look like this. I do. So I want it to have the face on the left side, some title, and I want it to have the time and the date on the right side. And I think, I came to day one of this conference, and this looks like that 3-segment in control. I must be doing something right. I've listened to designers. So I have an image, I have a text, a spacer pushes everything over that it can, and then I have a vertical view where I put my time and my date. And I run this, and I get this. I think, well, that's probably too big. So I say, really? My designer said they wanted the face to be 40 by 40, so what I'll do is I'll specify that the frame is 40 by 40, and I run again, and it looks like this. So, well, that's about right. How many of those can I fit on the page? So I don't understand, because it's clearly changed its size, but it's not 40 by 40. And then I find out that in order to change its size, you have to tell it that it's resizable. You'd think that'd be obvious if you told it, I want you to be this big, that it's resizable. But now that it's resizable, it looks like this. Now the face is a little too close to the left, and it's a little too close to the title, so I'm going to put padding around it. And notice I can put padding only on specific sides if I want, so that's kind of handy. And my image is looking better. I'd like to align it. I don't know. I read a book somewhere that maybe I should top align all those texts, and the things on the right should be right aligned so they look better. And so I'll set my, I guess I'll style my text first, so that the style of the text looks different. And now I'll align them. And I don't know if you've noticed, but we specify resizable and frame and padding after the component. We specify the font after the component, but alignment for some reason comes somewhere different. Now my theory is that's because Apple hates you, but that's just a theory I'm working on. You just have to learn the API over time. So we can set the alignment to be top aligned for all the things across, and I want to right align the time and the date. And so now I get something that looks like this, and now let's just give a little more breathing room to the time and the date. So I'll take my V stack and I pad it, not where I set the alignment, I pad it at the end for consistency. And now I get this. That was easy, wasn't it? That's just the look. How do I actually fill it with data? How I fill it with data is a problem for me because what I want here is an image, a text for the title, a text for the time, a text for the date. That's what I'm displaying. But when I look at my model is an enumeration. The moods are either despondent, sad, neutral, happy, or joyous. That's an enum. I got to get from that enum to that picture. I've got to get from my title to my title, well, that should be easy, a string. And I've got to get from a date to 2 strings. So what we use to do that is something called a ViewModel. And a ViewModel came out of Microsoft architectures when they were doing bindings like this, I don't know, 10 years ago. It's been around a long time. And so our ViewModel says, I know what the model looks like. When you want me to change this into something I can display, you just ask me. I'll take care of it. You have a string and you want a string, that's an easy one. You have a mood and you want to turn it into an image, I know how to do that. And so I'll put this code in the ViewModel. The ViewModel is like my adapter. It says, you have this, you want this, I know how to transform it for you. You have time and a date that you want. Well, I don't know. I have a timestamp that has a date object, but I know how to turn a date object into a string using a formatter, and so my job as the adapter is to turn one into another. So my ViewModel is how I fill that in. One more problem. I've got this mood, and I set a new mood, and I record it, and I look over at the history, and nothing has updated. And I'm sad. And I'm ready to quit. Because these are both talking to the same guy. They're both talking to the history. And so I added the new mood to my history, and I go over to my history, and I say, well, show me all your history. And it's still talking to that history, but to be efficient, it didn't say, well, you want me to update the view. It doesn't know it needs to check back with the history to see what's happened. So it's displaying the same history as before. So how do I get it to update? So here's history. History keeps all those records inside of it. History has the ability for me to add a new mood to it. So I add a new mood, and it says, okay, here's your mood, here's your title, I'll create a new mood. And it sends an update. And I'm also have the ability to clear all my records. So I'll remove all the records. I'll send an update. So what do I need to do an update so that the other guy gets it? Because right now, I've got this 2 mechanisms. I've got state and I've got binding. State says, look, when the button presses and changes the value, if the value is state, it says everybody inside of me who is depending on this value, update. And so that's how state worked. The second mechanism we learned was binding. Binding says, when you press this button, you're going to call this action. This action updates the value. This value is a binding. Nothing in here is depending on that. So I send that message back to whoever is holding on to my binding, and that's this guy. So my content view gets its state, and it says, I'm updating my state. Everybody that depends on state needs to know about this. So it sends the message to the value display. It's exhausting. And my text updates. So the binding says everybody's connecting to the state. But in my 2 views here, I can't use binding because I'm already getting the message that this guy updated. I'm just not getting the message that I need to refresh this view. So what object binding says is, look, you're connected with a history. I need to somehow let you know that something has happened. And so, history has to be a bindable object. And a bindable object is a reference type so that a message can be sent out and say, hey, this person updated. You need to update your view of him. And the updating happens through a publisher. And in this case, the publisher is called didChange, because that's what the examples always call it. So it's time for me to send an update. My didChange will say, hey, I've changed, really. You can take me back. So I send the message didChange to everybody that cares. So how do you care about changes? If you're the view and you want to say, I care about you, you form an object binding, and the object binding says, you tell me when you've changed, and I'll refresh my view based on that. So now, when I enter a new view, the history updates, and then I update my history to reflect that. And that, my friends, is the world of SwiftUI. Warnings, it is early days. Much of this will change. People were very upset when they saw this because it depended on things that Apple hadn't told us were changing in Swift. And all of a sudden, there were changes posted to Swift saying, here's how we're changing the language, what do you think? And people said, weren't you supposed to ask us first? And Apple said, yeah. So, the notation called function builder might change. The property wrappers are in the final stage of evolution right now. So it's early days, a lot will change, but whatever happens for developers, for anybody working on Apple platforms, this is our future. Apple is clearly pushing us in this direction, and so these are the changes coming in SwiftUI. Thank you.
Okay. So got a few questions for you from the audience.
Yeah, I'm not answering it.
All right, well, I'll just go back inside now. It's fine. So the first one, do you think that combined frameworks can fully replace other reactive frameworks like RX Swift?
Well, the combined framework is taken from a reactive framework, and we've just seen the first release of it. It certainly will change over time. We haven't seen Apple's plan for asynchronous code yet, and so over time, it certainly will. And the other thing is, when Apple, so they're third-party solutions to a lot of things, but when Apple ships one, we tend to use it because it's the one that comes with it, and so it's just easier for us to adopt it.
Perhaps a similar question is state asynchronous?
Well, no.
Easy one. Next question. Since it's only available on iOS 13, is there a way to handle previous iOS versions? And when do you think it'll be usable in real-world applications?
So this is a huge difference between Apple and Google. Google will often make different affordances so that things can be used before the release. Apple is very big on it works from here on. And so this is something that depends on changes in Swift, in particular Swift 5.1. So now that Swift ships with the OS, if you're depending on things in Swift 5.1, you can't ship it on something that doesn't support that version of Swift. So, no. Also, I mean, Apple's in the business of selling hardware. They'd love you to buy a new phone.
Similarly, do you think SwiftUI can replace UIKit immediately? Sounds like no.
Immediately, probably not. If I'm doing a new app, I would certainly embrace it. You can work with the two worlds right now. It also depends how far back you have to support. Many people have to support several OSs back, and so for them, the answer is no.
Do you have any techniques for doing sort of that parallelization while you have to support both?
I don't know.
Okay.
Isn't that an easy answer?
Yeah, that's great. Does SwiftUI replace the interface builder?
So if you're using Mojave, you don't get this live update. If you're using Catalina, then there is a view of your interface that is in parallel with your code, so you can add things in the interface builder and see the live updates in code, or add it in code and see the live updates in interface builder. It's very cute, it's very handy, it's not necessary, but so it won't replace it in let me put it a different way. Interface builder had to persist things somehow. And so recently it's persisted in XML. What it's really doing now is persisting it in Swift itself. So you're seeing the code behind the GUI look.
Okay. Do you have any experience with Flutter?
Do I what?
Any experience with Flutter?
No.
Okay. Then we're going to skip that one. I'm sorry. What should be the great advantage of mixing layout definitions and business logic code altogether? Couldn't this lead to enormous code files?
Well, yes, but you saw that I separate them out. I mean, I don't believe, just the way you can get big view controllers, or if you were raised correctly, you can split it into lots of view controllers, you can do the same thing with your view files. There's no reason for you to have huge view files that have everything in it, if you were raised right.
Okay. Is it possible to have read-only binding?
No, right now they're two-way binding.
How do you see SwiftUI evolving clean Swift patterns?
So it's kind of funny. We just saw it 3 weeks ago, and people are asking what's the best practices. We don't know yet. We don't even know what reasonable practices are. And the documentation is woefully way behind. Some of that I'm sympathetic with because it's dependent on these things that haven't solidified yet.
There are a couple of questions about Flutter and React. So how do you feel about the potential of this extending to other platforms other than iOS?
People ask this a lot on the list that, is Apple going to open source this for other platforms? They don't tend to be in the business of doing that. The only thing I can think of where they did that was WebKit, but that was a competitive advantage also for Apple. I don't see this being something that they're interested in doing. They're interested in Swift on the server, but this doesn't apply there.
Right. For people who are not developers, what do you think that they can take from this presentation back to their teams?
So for a long time, Apple's been looking for ways to say, you can work side by side with a designer and they can do this. And designers haven't tended to use IB, even when we do things like IB Designable. In their demo, they said, well, now they can sit next to a developer and tell them this and that. The biggest thing to take back, I think, is that pixel-perfect design is now officially dead at Apple.
And do you see SwiftUI as something that designers will actually adopt?
Well, what I saw 2 days ago at the first day of the conference was designers talking about these design documents that, in my mind, might not look very different than when we start breaking out these components. And so I can see designers being involved in helping spec these things and saying, here's how my buttons look in this situation, so let's write this button, and it just lives in Swift code. I mean, some of those things that we saw the other day didn't look very different than the Swift code.
And you mentioned it's early days, but from your point of view, what downsides do you see to jumping into SwiftUI right now?
Well, all your code's going to be wrong. I mean, we did this with Swift 1. I felt that pain because I wrote a very early book on Swift, and I've updated it every year. I intend to do the same with SwiftUI. I'm very excited and want to get in, but not only will the way we do it change, the way we think about it's going to change, and so we're going to find better practices as we go along.
And knowing that that's going to happen, how would you recommend people approach learning and getting into this?
Well, I mean, you've got to decide the risk you want to take at work. I would take a side project and just do it there. I don't know that I would do it in my mission-critical thing I have to ship in September.
So find some time to do it in a different track.
I would.
Okay, great. Thanks so much, Daniel.
Thank you.